started on today's notes over midpoint and distance in the coordinate plane. The first thing we're going to talk about is midpoint in the coordinate plane. We're going to use this midpoint formula to find the center point between two endpoints of a line segment that's been placed on the coordinate plane. So this midpoint formula determines the halfway point, both vertically and horizontally, between two endpoints. What we're going to do is we're going to add the two x coordinates and divide by 2 to find our middle halfway point horizontally. We're going to add our two y values and then divide by 2 to find the halfway point vertically. And when I add two numbers, divide by 2, that's the average, right? It's the center point between two numbers. Let's get started on example number 1. It says, determine the coordinates of the midpoint of segment DF with endpoints D, 4, 3, and F, -6, -2. I'm going to label these endpoints as X1, Y1, and X2, Y2. And then we're just going to plug them into our midpoint formula. So the midpoint is, I'm going to add my two X coordinates. So 4 plus -6, I'm going to write that down, 4 plus -6, and then I'm going to divide by 2. Then I'm going to add my y values, 3 plus -2, and then I'm going to divide by 2. My next step is I'm going to just simplify this one step at a time. 4 plus -6 is -2 over 2. 3 plus -2 is 1 over 2. And then I'm going to simplify this. The midpoint is -2 divided by 2 is -1, and then 1 over 2 is just 1/2. And that is my midpoint. Let's move on to example number 2. Find the midpoint of segment AB given that A is 7, -4, and B is at -5, 2. Then we're going to graph segment AB with midpoint M. So if you want, let's first graph A and B. A is at 7, -4. 1, 2, 3, 4, 5, 6, 7. Down 1, 2, 3, 4. This right here is where point A is. B is at -5, 2. So -5 is 1, 2, 3, 4, 5, up 2. There's where B is. So there's my endpoints. Let's find that midpoint using our midpoint formula. The midpoint, and I'm actually going to zoom out so you can see that formula up there. And I'm going to label this X1, Y1, X2, Y2. We're going to add our two X values. So 7 plus -5 plus -5. And then we're going to divide by 2. And then we're going to add our two Y values. -4 plus 2. And then we're going to divide by 2. Simplify one step at a time. 7 plus -5 is +2 over 2. -4 plus 2, that's -2 over 2. And now we're just going to simplify. Our midpoint is 2 divided by 2, which is 1, and then -2 divided by 2, which is -1. That's our midpoint. So 1, -1, 1, -1, that is our midpoint. And then we're just going to graph this. Or draw my line, connecting those endpoints and going right through that center, that midpoint, right? It divides that line segment in half. Okay, so that's how we find midpoint on the coordinate plane. Let's move on to finding distance in the coordinate plane. The distance of a line segment, that's the length of a line segment. We're going to use this distance formula to do this. And this distance formula is the square root of, I'm going to subtract my x values, square those, add it to the difference of the y values squared. Now this formula is actually derived from the Pythagorean theorem. So let's write this down. It's derived from the Pythagorean theorem. And you may recall this from 8th grade. The Pythagorean theorem, a squared plus b squared equals c squared. What do we use the Pythagorean theorem for? We use it to find the lengths of the sides of a right triangle. A being a leg, B being a leg, and C being the hypotenuse. So c squared, if I wanted to find the length of this hypotenuse right here, or the distance, I would get c all by itself by taking the square root of both sides. So that's how we get this distance formula, right? We're finding the length of A, okay, which is it's just A squared, right? So here's A squared, B squared, here's B, and then we take the square root of both sides. So the distance formula determines the distance, which you might also see as D, between 2 points on a coordinate plane. Let's move on to example number 3. Find BC, which means the length of segment BC. So let's write that down. This means the length of segment BC, right? So when you have two capital letters and they're italicized, that's the length of BC. So I'm going to say that whenever I'm doing this. Find the length of segment BC when B is 8,3 and C is at -2, 5. So let's label this x1, y1, x2, y2, and let's plug this in to our distance formula. So we're going to subtract our x values, x2 minus x1, okay? Well, that's going to be -2 minus 8. -2 minus 8, we're going to square that, add it to y2 minus y1. That's 5 minus 3, and then we're going to square that. And as we go through this, we're just going to do one step at a time. So the first thing I'm going to do is -2 minus 8. Same signs, add and keep, right? So -10 squared plus 5 minus 3 is 2 squared. Okay, next step. We're just doing one step at a time. So D equals the square root of what is -10 squared? That's -10 times -10, which is 100, plus 2 squared is 4. Next step, D equals the square root of 104. Now, am I done? No, you cannot forget to simplify. Let's see. Right here, don't forget to simplify. To simplify. So when I have a non-perfect square root, I want to make sure that I simplify it the most it can be simplified. So you've probably already been given a review lesson. If you've been going through my lessons, I do have a review video of simplifying non-perfect square roots, and I'll link that video in the upper right corner of this video. If you need a review over simplifying non-perfect square roots, just click that link. I'm going to go over that though. The square root of 104. How do I simplify this? I want to find the biggest perfect square that goes into 104 a whole number of times. That means the biggest perfect square that's a factor of 104. And that's 4. 4 times what is 104? 4 times 26. So the square root of 4 times the square root of 26 is the square root of 104. Now we're going to simplify the square root of 4. What is the square root of 4? It's 2. So 2 times the square root of 26 equals the square root of 104, which means the length of BC is 2 square roots of 26, or 2 root 26. Let's move on to example number 4. Okay, and I'm going to leave that formula up there so we can refer to it as we're filling this out. Okay, so this says find the length of segment RS given that R is at O -3 and S is at 8, 6. Then we're going to graph segment RS on this coordinate plane. Okay, so let's plug this into our distance formula. First, I'm going to label this x1, y1 and x2, y2. And then I'm going to plug it into d equals, what do I do here? I'm going to x2 minus x1 and square it. So 8 minus 0, and then I'm going to square that. Added to, subtract my y values, 6 minus negative 3. So look what that looks like. 6 minus negative 3, and then I'm going to square that. All right, let's move on to our next step. Now I'm just going to simplify this one step at a time, okay? So d equals the square root of 8 minus 0 squared. Well, that's just 8 squared plus 6 minus negative 3. Well, that's the same thing as 6 plus positive 3. So, all right. Can I do this? Okay. 6 plus positive 3, that's 9. 9 squared. Now the next step. Let's move on. See if I can change colors here. Moving on to purple. Okay, simplifying one step at a time. 8 squared is 64. 9 squared is 81. And now we're going to add 64 plus 81. I'm changing colors here. And I get 145. So the d equals the square root of 145, which I cannot simplify, which means the answer to this one is, therefore, the length of segment RS is the square root of 145, and that's just what it is. And now let's graph all of these points. So I'm going to graph point R at 0, negative 3, and S is at 8, 6. So I'm going to go right 8, then up 1, 2, 3, 4, 5, 6. So this is point R, this is point S, and the distance between those two is right here, is the square root of 145. And that's how I would write my answer. Let's move on to the next page. We've got a couple practice problems here that might look a little different than what you've seen. In problem number 5, it says M is the midpoint of segment GH. Given that M is at 3, 2 and G is at 6, 6, find the coordinates of H. So in this particular problem, we're given the midpoint and one endpoint, and we need to find the other endpoint, okay, the location of that. So the first thing we're going to do is we're going to let G equal XY. Okay, so this is X, and I'm just going to call it X1, Y1. Okay, then we're going to use the midpoint formula, and I'm going to write this down because I don't have it, and I'm going to zoom in here. It's on the other page. So recall that the midpoint formula is x1 plus x2. So I'm going to add my x's, divide by 2. Then I add my y's and divide by 2. And then we're going to, using that midpoint formula, we're going to solve for x and y. So watch how I do this. The midpoint is at 3, 2. So the midpoint is 3, 2. And we're going to set that equal to, I'm going to add x1, which is 6, plus x2, which we don't know that other endpoint. And we're going to divide by 2. We're going to do the same thing with our y values, 6 plus y2. And we're going to divide by 2. Okay, so how do we do this? The first thing I'm going to do is I'm going to find my x coordinate. And let's write this down. Find x coordinate. All right, what do? I'm going to set 3 equal to this right here. 3 equals 6 plus x2 divided by 2. And I'm going to solve for x2. How do I do that? How do I get x2 in my numerator all by itself? Well, I need to get rid of that denominator. So how do I get rid of divided by 2? I multiply by 2. What do I do to one side? I have to do to the other. 3 times 2 is 6 equals 6 plus x2. If I want to get x all by itself, I subtract 6 from both sides, and I get 0 equals x2. So that's my x coordinate. That's one endpoint, okay? Or I'm sorry, one coordinate for the endpoint. Let's find the other one. We're going to find our y coordinate, and we're going to do the same thing we just did for our x coordinate with our y coordinate. I'm going to set this to equal to this over here. I'm going to set up this equation. 2 equals 6 plus y2 divided by 2, and I'm going to solve for y2. I'm going to multiply both sides by 2, so I get 4 equals 6 plus y2. I subtract 6 from both sides to get -2 equals y2. And that's my point, okay? So let's write that down. Point H is found at 0, -2. Those are the coordinates for the other endpoint. So when you're given a midpoint and one endpoint, this is the process you're going to use to find the coordinates of that other endpoint. Let's move on to this last little problem for distance. This says, use the graph to find the length of AB and the length of CD. Then determine if segment AB is congruent to segment CD. So recall that our distance formula is the square root of, I subtract the x values, square it, add it to, I'm going to subtract the y values and square it. Okay, so that's our distance formula. So the first thing we're going to do is find the length of segment AB, or the distance. So first let's write our coordinates down. So go ahead, I would pause the video and write your ordered pairs for the endpoints A and B. Endpoint A is found at -8, 1. And endpoint B is found at 3, 9. Okay, and we're going to use those points and plug them into our distance formula. So we just need to make sure that we plug everything in correctly. So x2, and I'm not labeling anything, it's just you're going to subtract your x values and subtract your y values. So x2 minus x1, so let's do -8 minus 3. -8 minus 3. We're going to square it, add it to 1 minus 9. I'm subtracting my y values, and we're going to square that. So one step at a time, -8 minus 3 is -11, so -11 squared, plus 1 minus 9 is -8 squared. Next step, -11 squared is 121, plus -8 squared is 64. Then I'm going to add the square root, 121 plus 64 is 185. So I get the square root of 185. And let's move on to the other line segment. The other segment is segment CD. So, and we're finding the length, and then if the lengths are the same, what does that tell me about the segments? They are congruent. So if the lengths are equal, then the segments are congruent. So point C is at -4, 2. It's the ordered pair for C. Point D is at 7, -6. That's the ordered pair for that. So now let's plug in those points into the distance formula. We're going to subtract our x values. -4 minus 7. -4 minus 7 squared. And you can do 7 minus -4, and you can square that, right? But, whatever order you go in, it doesn't matter. Okay, then we're going to add it to 2 minus -6. 2 minus -6 squared. And now, one thing at a time. -4 minus 7 is -11 squared. And the reason that didn't matter is if you did 7 minus -4, that would be 7 plus 4, which is +11. Positive 11 squared is the same thing as -11 in parentheses squared. Plus 2 minus -6, well, that's the same thing as 2 plus 6, which is 8 squared. Then I get -11 squared is 121, plus 8 squared, which is 64. which is the square root of 185. So here's what we have found. We have found that the length of AB is equal to the length of CD. That's what we have found here. Therefore, segment AB is congruent to segment CD. And that concludes your notes over midpoint and distance in the coordinate plane. I hope it was helpful.